right. Good morning, everybody who's joined us. I can't see who's online, but we do have an avenue for y'all to ask questions today. We're running 30 seconds to 45 seconds delay, so if you ask a question, you're going to type it in. So don't worry if I don't get to it right away. It's going to be just a little bit of a delay. All right, you guys, today we're doing differential equations with slope fields. And you're going to need note 77, which looks like this. And then you're also going to need assignment 77, which looks like this. There's only one problem today that needs a calculator. And if you don't have one, it's not a big deal. I've got mine up here, and we can go from there. All right, I say this every year, and every year I forget, but we're not doing the bottom part of this page. You can just put an X through that. One of these years I'm going to remember that I don't want that there. All right, so yesterday we talked about slope fields. So what you're looking at in front of you are two distinct slope fields. And when drawing slope fields, so we have dy dx is 1 over x. And we talked about this yesterday. We're depending only on x in this case. So again, go back to your basic algebra. An x equal line is this or this. Well, of course, it's this. So all my slopes are going to be vertical if I'm dependent on x only. And you can see that illustrated here. If you look vertically, all the slopes are the same at x equal 1, at x equal 2, at x equal 3. In the next example, we've got dy dx is 1 over 2y. And again, my only variable in this derivative is y. So y equals. So now all my slopes are going to follow horizontally at y equal, and whatever y equals. All right, so again, that's just sort of a reiteration from yesterday. All right, let's go to the back. It's always intimidating when we have one problem on a whole page. But here we go. Again, I have to impress upon you guys, differential equations look awful, but they're really not. And we're going to separate. We're going to integrate. We're going to add a constant of integration. And we're going to use our initial condition to find our function. Out of a 9-point question, you're looking at 1, 2, 3, 4 very easy points. You can probably pick up 0.5 and 0.6, 7, 8, and 9. It depends on what the problem is. But again, if you can do that, you're beating the odds, and it's very easy to do this. Before we start with that, let me just come over here and draw a little border for us. If I am integrating dx, what do I have? Well, remember, there's the 1 there, so I end up with just x plus c, right? All right, well, we understand that, but let me ask you this. What if we're integrating dy? Well, that changes a little bit. Now, again, you just have the 1 there, but now you're integrating with respect to y. So your answer will be, of course, y. The derivative of y is 1, and that's what you're integrating, that unwritten 1 right here. If we're integrating dt, then we have t. And if you're integrating dp, of course, you're integrating for the variable p. Put that aside because you're going to need to rely on that as we move on. All right, so here we go. dy dx is sine x plus 2, and they've given us an initial condition, and we did not have that yesterday. So this is what's new. By the way, you can only separate by multiplication or division. You're not going to add or subtract. So for instance, I'm not going to subtract this 2 from both sides and move it over here. It's staying where it is. But I've noticed I've got my dy and my dx, and there's an x on the right side of the equation. I don't know my right from my left. You all know that. So here we go. What I'm going to do is I'm going to multiply both sides by dx. So that isolates the dy, and I have sine x plus 2 dx. All right, there's your separation. Now, this next thing is integration. So the antiderivative of dy is y. The antiderivative of sine Well, it's positive sign, so be careful. So you're going to have negative cosine x plus 2x plus c. All right, so here's what we've got. We've got a separation point, we've got an integration point, and we have a constant of integration included in our equation. All right, that's where we are now. And now we want to solve for the actual equation. And they've given us this initial condition of y of 3 is 5. So I'm going to plug in y is 5, negative cosine 3, 2 times 3 plus c. It's unlikely you're going to score a point for that, but what you're doing is trying to find out what this constant of integration is. So we have 5 negative cosine 3 plus 6 plus c. I'm going to move the 6 to the other side. Well, actually, I'm going to bring the 5 over here, and either way, I'm going to end up with a negative. I think what I'm going to do is move the 6 to the left. So I've got negative 1, negative cosine 3 plus c. And then I'm going to add the cosine 3 and isolate the constant of integration. So again, if you have your calculator, that's great. If you don't, I'm not showing up. Let me see. Hang on a minute. Okay, there we go. Clay, you're in radians. So cosine 3 minus 1, and the value of my constant is negative 1.989. Okay, easy peasy. There we go. Therefore, the equation y equal negative cosine x plus 2x minus 1.989. So again, let's run through our points here on this. You've got a separation, integration, constant of integration, solving for c, and then coming up with your equation using the initial condition. So 5 fairly easy points. Now, of course, your free response question is going to have more in it than that, but there's 5 fairly easy points on these problems. All right. Any questions?
Not yet.
Okay. All right, you guys, let's go to the assignment, and then we can actually work some problems together. Okay, I think what we're going to do, let me see how much time. Oh, okay, we have plenty of time. What I think I'm going to do is I'm going to work problem 1, and then I'm going to pause and let you work problem 2, and then we can ask questions as we go along. So on number 1, I've got dy dx. Draw a slope field for the following differential equations. So when they're asking you to do that, they're not asking you for the function. All they want you to do is the slope that goes along with this. So we're going to do a table of values, x, y, dy dx. Now again, you can kind of see you've only got y in your equation. So again, y equal, we're going to be across horizontally. And we can just understand that as it is. So if I'm plugging in 0, 0, well, there's no place to plug the x. So I've got dy dx is 0 minus 1. I end up with a slope of negative 1 whenever y is 0. So we're going to go to there, and when y is 0, we've got a slope of negative 1. And I'm going to fill that in. If you're lucky enough to get one of these questions, they won't ask you to fill in a graph that's 10 by 10. It'll be just 4 or 5 spots on the graph. But anyway, let's move on. Let's move to 0, 1. So at 0, 1, if I plug in the 1, 1 minus 1, my slope is 0. And I'm going to put in 0 slopes all across y equal 1. And then, of course, the next logical point, well, at least as far as I'm concerned, I'm going to put in 0, negative 1. And now I've got negative 1 minus 1. So my slope when y is negative 1 is negative 2. Down 2 and over 1. Again, I know it's hard to draw. What I'm doing is I'm going down 2 and over 1. I'm kind of shooting for that just to get close enough. And there you go. All right, take a minute and try problem 2. Notice what you're dependent on. Do a table of values and just sketch out what you think is appropriate. I can't use that operation. Okay, let's see if we agree. So I did 0, 0, 1, 0, and negative 1, 0. And I'm ending up with slopes at 0, 0, negative 1. And again, it's an x equal line, so vertically. I'm sorry, yeah, I got it right. All right, and then at 1, 0, I've got 2, and at negative 1, 0, I've also got a slope of 2. Do we agree? Any problems?
Not yet. No
Not
questions
yet. Okay.
But they can feel free to ask questions on the chat.
Yep, absolutely. The problem is, if I make a mistake, there's no one sitting here to tell me. No, Ms. Speer, it's positive, not negative. So here we go. All right, let's look at problem 3. They're giving us, what, 1, 2, 3, 4, 5, 6, 7 different functions running through here. And they're asking us, they're giving us a condition, dy dx is 2 times x minus 1, and they're giving us this initial condition. So they're pointing out 3, 2, and they want us to find the function there. So here we go. We've got dy dx is 2x minus 2. I'm just going to combine it. What do we do first? We're going to separate. We're going to get the x's on one side, the y's on the other. And again, that's nothing you haven't been doing since Algebra 1, just getting all your like terms together. Separation's not anything novel or complex. All right, there's our separation. Now our integration. So the antiderivative of 1 dy, y. And then you've got antiderivative of 2x, so x squared minus 2x, and of course our constant of integration. So we've got our separation, our integration, our constant of integration. Now I'm just going to, there's not a lot of room to work here. They gave us this initial condition of 3, 2. So I'm going to plug that in and solve for C. Okay, easy enough. Therefore, our function is y equal x squared minus 2x minus 1. Easy? Okay, I'm going to let you do 4 in just a minute, but I want to jump ahead to 5. Okay, in 5, notice the instructions, solve the differential equations, but you're not seeing a dy dx. Well, you are. They're just using a different notation. So they're starting me off with my second derivative, telling me it's sine x. So I know my first derivative is the integration of my second derivative, right? We're working backwards. So I know my first derivative is the integration of sine x. All right, so let's find our antiderivative. sign's positive, so negative cosine x plus c. And you'll notice they've given you an initial condition for the derivative. So f derivative 0 is 1. So I've got 1 equal negative cosine 0 plus c. So I know my derivative is equal to negative cosine x plus 2. All right, but that's not what the question's asking for. They want you to go all the way back to the function. So we need to do this one other time. So I know the function is the integration of my derivative. And I found the derivative, it's right here. So the function is going to be the integration of negative cosine x plus 2. You can write the dx, but it's kind of understood at this point. All right, so here we go. Our antiderivative that's kind of hard to see, sorry. Negative sine x plus 2x plus c. And again, they've given us an initial condition for the function. So we know 6 is negative sine 0, 2 times 0 plus c. Sine of 0 is 0 and 2, 0. So c is 6. So our function, and I'm really out of room and I'm sorry, is negative sine x plus 2x plus 6. Okay? All right, take a minute and work problem 4. And I'm going to have to, well, I guess I really don't. I'll just work it on another piece of paper and put it up there. That way you still have it. All right, so we had to take care of something while we were out. So here we go. We know the derivative is the integration of x squared, the second derivative. So my integration 1/3 x cubed plus c, my initial condition of 0, 6, c equals 6. There's the derivative, 1/3 x cubed plus 6. Good? Questions?
No questions yet? You're
Okay.
still,
I'm impressed with them.
They're doing good.
They haven't been here in a while. This is pretty impressive. All right, so the function is the integration of the derivative, so 1/3 x cubed plus 6, 1/12 x to the 4th plus 6x plus c. They gave us the initial condition of 0, 3. F of 0 is 3, therefore c is 3. And our function is 1/12 x to the 4th plus 6x plus 3. Okay. I'm moving on unless y'all type something in. All right, hang on one sec. All right. And again, find the solution of the differential equation. Now it looks more like a differential equation. Now we've got the change in p with respect to time, the change in y with respect to x, the change in s with respect to t, et cetera, et cetera. So I think what I'm going to do is I'm going to work 6. Y'all are going to work 7. I'll work 8. You'll work 9, and so on and so on. So here we go. Problem number 6. dy dx is 6x squared plus 4x, and they're giving me an initial condition y2 equals 10. So we're going to first separate. I need the dx over on the right side. So dy 6x squared plus 4x dx. And now you can integrate both sides. So I end up with y is, 2x cubed, 2x squared plus c. Okay, we've separated, we've integrated, we've added our constant of integration. All right, the initial condition, y of 2 is 10. So 10 is 2 cubed, 2 squared plus c. 2, 4, 8, 16. 8. I'm getting negative 14. See if you agree. Good. Okay, so there we go. Our function 2x cubed plus 2x squared minus 14. All right, take a minute and work problem 7. dp dt is 10 e to the 10th. Antiderivative of e to the x. King don't care. All right, work that one real quick. All right, here's what I've got. I kept dp on the left. I moved dt to the right. That gives me the ability to integrate e to the t and also dp. So separation, integration, constant of integration, initial condition. Good? Still no questions? They're just rolling through this. I told you, best kids in the world, right? Yeah. All right, let's try number 8, ds dt. And again, it doesn't really matter what the variable is. You just get your like terms together. I've got t's on the right side of the equation, so I'm going to move dt. So ds is negative 32t plus 100 dt. Here's our separation, our integration. See if we agree. S of 0 is 50. So 50 is 0, 0, C equal 50. Therefore, S is negative 16t squared plus 100t plus 50. Okay. All right, that's going to make number 9 seem pretty easy. And again, I don't have a freeze button, so I'm going to just take this off the screen while you work problem 9. Okay, here we go. You got a question? We good? Okay, I'm moving on. Let's look at 10. This was the notation that fuzzed y'all up in derivative quests. D squared y dx squared, remember that's your second derivative. So they're starting you out with your second derivative, which is 3e to the x plus 5 sine x. They're giving you a condition of the function, and they're giving you a condition of the first derivative. So this will be just like what we did on the front for problems 4 and 5. So I know, first of all, we're going to do our separation. Okay. And you're just going to run with this just like it's a regular first derivative. It's not, it's second derivative, but that doesn't matter. So we're going to integrate. Now if you're integrating the second derivative, it's going to take you back to the first derivative. Okay? And 3e to the x is simply 3e to the x. And then I've got sine is positive. So remember, your antiderivative is going to be negative cosine. Negative, negative is positive. And then, of course, you've got your constant. So now you're saying in a different notation that the integration of d squared y is dy, which is your first derivative, of course. Now we're going to use this initial condition for the derivative. Y derivative 0 is 2. So we've got, what, 2, 3e to the 0, 5 cosine 0 plus c, which gives me 2, 3 times 1. Cosine of 0 is 1 plus c. I'm kind of out of room. So now I've got 2 is negative 2 plus c, c equal 4. So my first derivative is 3e to the x, 5 cosine x plus 4. Okay? Well, now you're ready to, well, let me back up here. You have two options here. One, you know it's dy, but it's with respect to x. So the dx is sort of understood there, since our notation's a little bit different. So I would just leave it like this, and then I know I'm going to be integrating. So you're just going to go from there. And the antiderivative of the derivative of y, of course, is just y. And now you've got 3e to the x. Antiderivative of cosine is sine. And there's your constant. And again, that negative's in there. So forget the negative 5, but the derivative of sine is cosine. We've done the right thing. The negative 5 is just the constant in front of it. And our condition for the function y of 0 is 1. So 1 is 3e to the 0, 5 sine 0, 4 times 0 plus c. Well, of course, sine 0 is 0, that's 0, and this is going to leave you just 3 times 1. So your c value is negative 2. So our function y equals 3e to the x minus 5 sine x plus 4x minus 2. And again, I ran out of room, but that's not a big deal. Okay? All right, take a few minutes. Work problem 11. If you have questions while you're working, just type them in, and we'll go from there. Not a problem.
Man, you're doing awesome. I mean, you got your eye contact with the cameras.
This is awkward, to say the least. This one's going to take a little more time because they've got to integrate twice. I don't want to interrupt you guys, but are you ready? Are they saying in yes or no?
They haven't said anything yet.
Okay.
We're gonna chat. He's gonna chat to your see if
What's that?
are you live right now?
I think so.
Oh, okay.
Uh-huh.
We're gonna send it to the chat, just make sure it's working.
Go ahead. Can you?
Okay.
Yeah. All right, you guys, here we go. Let's start with the left side. I've got d squared y is 12x squared minus 6x plus 2 dx squared. So, of course, we're starting with our second derivative. We're going to integrate that. By the way, I get this question a lot. Once you've separated it, that's clear to see. Your reader can understand that. And if you want to throw your integrals in there, you can. They understand what you're doing. You don't have to make a separate step with the separation and then rewrite the whole thing again with the integration. We understand what you're doing when you throw your integration into the separation. So we've got dy is 4x cubed minus 3x squared plus 2x plus our constant. Our initial condition with the derivative was 211. Just be careful, make sure you know which initial condition you're putting in. So there's the 11 and the 2 plugged in, and we have a c value of negative 13. Everybody good? All right. Moving on, then we have dy is, what do we have? 4x cubed minus 3x squared plus 2x minus 13. Again, if you want to add the dx, it would be nice. It just tells your reader that you know what you're doing, but clearly you would anyway. And then there's your integration. So now the antiderivative of 1 dy is y, x to the fourth minus 3x squared, or excuse me, minus x cubed plus x squared minus 13x plus c, and now I'm using this condition of 0, 1. Of course, it's going to be 0, 0, 0, 0. C is going to equal 1, and here is your original function, the function. We're a little bit ahead of time, and since, well, I'm going to wait. Questions, are they coming through? No questions?
Questions yet?
Okay, we may switch to this forever. No, this is nice. I don't have to worry about y'all asking anything. All right, you guys, I know it's a lot for one day, but I would like to go ahead and move on since we have you and we've got 15 more minutes. Separation of variables gets a little dicey. And so what you're going to be doing, and again, I don't want to burden you too much, but let's just start with the notes on this because this was going to be a 2-day lesson anyway. Separation of variables is, it's not difficult, it's just time consuming. So the other thing I was going to ask you guys, I don't think I put, we've got this quiz, slope fields and antiderivatives. I don't think I put it in your packets, but I will. I'll send out a blank copy and you can work it tonight. And then tomorrow we'll go over it and see how we did. I'll send that out on Remind and email. By the way, I'm sending reminds and emails in case you're not getting one or the other. They're going to be exactly the same. So it's not like if you're getting the Remind, you don't have to click on the email. If you're getting the email, you don't have to click on the Remind. I know you guys are getting a lot of communications from all your teachers. So we just want to be sure we're covering the bases while we're apart from each other. All right, here we go. Separation of variables. All right, separation of variables. For those of you who are moving on to higher level math in college, you're going to take this class, and it's called Diff-EQ, differential equations. They're going to give you a whole semester of Diff-EQ. Anyway, we're going to start off pretty easy. And again, you know most of this, so it's really not anything new here that we're going. Again, notice we are in a box and it is black and it is heavily labeled purple glitter moment. I've got it here. You probably don't have any at home, but you are not separating by addition or subtraction. You are only separating by multiplication and division. All right? If I was to look at a slope field for dy dx is x cubed, right? X equal, all my slopes will be the same vertically. It's dependent only on the x value. If I'm looking at dy dx is y, horizontal, dependent on the y value only. Dy dx is xy, well, that's a different situation. Now you're going to have a combination. So there's no set rule when you have both variables involved. All right. Variable separable, well, yeah, we're not going to be doing anything that's not at this level. All right, so here we go. Dy dx is negative x over y. You ready? We're going to separate. Now I've got to move the y to one side and the dx to the other. I'm getting get all my y's on one side and all my x's on the other. So now I've got y dy is negative x dx. All my like terms are together. Easy. All right, we're going to integrate. And again, your integration rules, it doesn't matter what variable you're working with, your integration rules stay the same. So the antiderivative of y is going to be 1/2 y squared. Now, you're not going to add a constant of integration to the y side, only to the x side. And that's going to equal negative 1/2 x squared, and there's my constant of integration. So again, whatever variable's on the left side of this, you're not adding the constant to, you're adding the constant to what would be the x side. Okay. We have separated. Remember, this is your x, that's your y. So I've got 1/2 negative 3 squared, negative 1/2 2 squared, plus c. All right, so we end up with 9/2, negative 4/2, plus c. I'm going to move the 4/2 to the other side. 9/2 plus 4/2 is c. c is 13/2. Okay, we're going to put it all together. So we have 1/2 y squared negative 1/2 x squared plus 13/2. And you're going to think you're done at this point, but you're not, because we have a y squared equation here. So we're going to have to get y by itself. And the very first thing I'm going to do, just to make this a little bit easier, is I'm going to get rid of this denominator of 2. I'm going to multiply everybody by 2. So I've got y squared is negative x squared plus 13. Sometimes it works out very clean like that, sometimes it does not. We're going to take the square root of both sides. And we're going to have y is, and remember the square root of 25 is 5 and negative 5. You're going to have plus or minus. Negative x squared plus 13. Now, how do I know which one's my answer? Well, let's go back to our initial condition. If I plug a positive x into this, I get out a negative y. Well, whatever's under this radical has to be positive, so my answer is going to have to be the negative side of this. You're only going to be able to pick one answer in most cases. So again, that initial condition, which seems innocent as we're looking at it, really plays a heavy role in this, because as I'm looking at this, well, I can't have the positive side, because when I put a value in, I get out a negative answer. Remember, your y square is graphing like this, so you are choosing the negative side. All right, I think, well, we still have 5 minutes. So how are we doing? Questions? Anybody typing anything?
I have a bunch, but they don't have any.
That sounds good. All right, you guys, we're probably not going to get all the way through this, but let's at least look at what we've got here. All right, I've got ds dt is the square root of st. All right, remember, one of our rules with roots is that we can separate them. So we have the square root of s over this, and excuse me, times the square root of t. Now I want all my s terms to one side and all my t terms to the other. So here we go. To get rid of this square root of s, I'm going to have to divide by it. And to get rid of this dt, I'm going to multiply. So take just a minute to think that through. If I want to move this s, I'm dividing by root s, and I'm doing it on both sides. That crosses this out here and actually leaves me ds over root s dt, and then of course I'm multiplying by dt, and that moves it to the other side. So now we're going to be integrating. So I'm integrating s to the negative 1/2 ds, and I'm integrating t to the positive 1/2 dt. Whoops. Again, please don't let this mess you up. If you have to come over and do this separately, there's nothing wrong with that. Right? So my integration of s to the negative 1/2 is going to be 2s to the 1/2. We agree? And when I add 1 to this, I get 3/2, so I've got 2/3 t to the 3/2. Hang on. I was about to write dt again. Seriously? Oh, close enough. Plus my constant. All right? Oh, we may have time. So we have 2s to the 1/2 is 2/3 t, thank you, to the 3/2 plus c. All right, now they're telling us t equals 0 when s equal 1. So we've got an initial condition right here of t value and s value. So we are going to plug that in. And you end up with a c value of 2. But they also want to know, what is s when t equal 9? I think at this point we're probably going to have to shut down. Let me write the function real quick. So we have 2s to the 1/2 is 2/3 t to the 3/2 plus 2. And now what is the s value when t equals 9? Of course, you're just going to plug in nine for t. All right. I think we have a minute. Is that about right? Okay, so I'm going to shut down there because the answer to this is going to take a little bit longer, and I don't want to rush this. If you want to go ahead and work it tonight, you can. But I think we're in pretty good shape. I'll send the quiz out tonight, work on that, and then we'll check that tomorrow, and we'll keep going with separation of variables. Okay, last call for questions. Type fast if you have any. No? Nothing?
Not yet.
All right. Hey, okay, you guys, so here's what's going to happen. We're going to meet on Monday, Tuesday, and Wednesday, which will take us pretty much through this unit, and then we'll do online review and online testing after that. Once we're done with that, we move into the AP practice for the AP test. Hopefully we'll be back in school by that time. But have a great weekend. I will talk, wait, today's Wednesday, right? Okay, I will talk to you then on Monday. Miss you guys. See ya when we see you. All right, bye.